This video is about rational functions, specifically finding the horizontal asymptote. Now, there's a lot of different pieces to finding rational functions if you were going to graph it per se or define other important information, but we're specifically focusing on the horizontal asymptote. And if you want to see all those other pieces, go ahead and feel free to search through my YouTube channel to do that. But specifically, there are three different types of horizontal asymptotes, or three different scenarios. I covered a video where I did if the highest exponent is the same on top and bottom, or in the numerator and the denominator. I also covered a video where what happens if the highest exponent is in the numerator and then something lower in the denominator. So make sure you check out my YouTube channel for that. But this video is about when finding the horizontal asymptote, what do you do when the highest exponent in the numerator is smaller than the highest exponent in the denominator, which we're going to discuss right now. So, taking a look, the highest exponent on the variable in the numerator is an invisible 1, and then on the bottom it's x to the third. So, right, I have 1, the highest exponent I have in the numerator is 1, the highest exponent I have in the denominator is a 3. So that means I like labeling it like this: small over big. Right? Small over big. And actually, this is quite simple. This is the really simple one here. So if it's small over big, that means, essentially, if you think about it this way, if I were to plug in numbers for x, right? If I were to plug in 1, if I were to plug in 10, if I were to plug in 100, right? On the top, x to the first, well, 1 to the first power is 1, and then 1 to the third power is 1, so that's not a good example. What if I plug in 100? Right, 100 to the first power is 100, but 100 to the third power is, I think, actually going to be 1,000,000 or 10 million. I quickly did the math there. But if you continue that pattern, right, it's actually going to get closer and closer to somewhere, and it's actually going to get closer and closer to 0. Okay? So rather than having to do that math every time, like, well, let's plug in numbers and see. The pattern is, no matter what type of rational function it is, if the highest exponent is on the top, the highest exponent on top is less than the highest exponent on the bottom, small over big, then it's just the horizontal asymptote is y equals 0 every time. That's really all. That's all there is to it. So the theory behind it is, remember, if I were to plug in a number for x in this problem, if the exponent on the bottom is bigger, that means my denominator is bigger, meaning actually the number gets smaller, right? The bigger the denominator, the smaller the number is, depending on what the numerator is. But remember, the numerator and the denominator have the same x, meaning it's actually, the denominator is going to grow bigger than the numerator will. So when it's small over big, the horizontal asymptote is y equals 0. Here's another example just to see if you get the idea. Here we go. So notice in this problem, again, the highest exponent in the numerator is that invisible 1. The highest exponent in the denominator is a 4. So 1 over 4, meaning small over big. Meaning, again, I don't need to do any math. I just know that the horizontal asymptote for this function will be y equals 0. All right, so that's what you do when it's small over big. Like I said, there's two other scenarios, which I have other YouTube videos for. Feel free to check those out.